The first time around, and we realised that the concentrations of the sulfuric acid were not high enough. So I saw a little bit, but I didn't see enough. Definitely not YouTube. Okay. So
is this for your YouTube channel?
it is for my YouTube channel. It is. It is indeed. It is indeed. Which in turn is there for students as well. Okay, so the other thing I've also got is in testing, I realised that this rock salt is not pure rock salt. Okay, so it's got sodium chloride in it, but at the same time, and I'll show you this one as well. At the same time, it's got potassium iodate. Okay, so the iodate actually causes other products as well. So when I was checking it, I was like, no, this isn't enough. So we don't have available sodium chloride. I don't know why. I just couldn't find it in time, but this should work with group 1 halides. Okay, so this is a potassium chloride. So the thing that we're looking out for are white misty fumes. Okay, the white misty fumes are indicative of hydrogen chloride. Okay, so right. I'm just doing this outside because it's just safe. So I've got a nice lump. So what I'm going to do is I'm going to put the lump. So if you want to, obviously you have to be a trained professional to do this, right? But what I'm going to do is I'm going to put the lump of the chloride insofar as far away from this side as possible. And what I'm going to do is I'm going to put some sulfuric acid. So I'll do that for each and every single one. Okay, now this is the decent sulfuric acid. I did try this out. Okay, so what I'm going to do is I'm just going to, and what was quite interesting was that there was a little cakey layer at the top. So that wasn't on the first trial. As for the chemistry behind that cakey layer, that's for another day. Okay, so here we go. Right, so what I'm going to do, now you're going to have to zoom in. What I'll do is I'll add it, and then you'll see a fizz, and then I'm going to see if there's something else. Okay. All right. So ready. All right. So just that much is sufficient. Okay. All right. So as soon as it's in contact, now get a right proper zoom of this. This is Fayad helping out. Hi. Say hi, Fayad.
Hey, Fayad.
Okay, so immediately you get a gas that's being produced, okay? Immediately there's fizzing, all right? So that is the hydrogen halide, that's the hydrogen chloride, okay? Now, if there are impurities, if there are other halides, then you'll get sulfur gases coming, so sulfur dioxide, okay? So what I was hoping to have is white mistiness come from there. So I'm going to add a little more of this concentrated sulfuric acid. Okay. Ah, did you see it? Did you see the fumes come from it? Okay. It's very small quantities, but I'll see whether I can take it off. All right. And show you. So the hydrogen halide should come off as a white misty fume. Okay. There's definitely a sharp smell. There's definitely a sharp smell. Fayad, I'm not sure whether you can smell the sharpness of that.
Kind of.
So there's definitely stuff. Okay. So that is the hydrogen chloride coming off. Okay. Now I'm going to keep it on there, just in case there's like a cloudiness that forms inside the petri dish. So if the cloudiness forms inside the petri dish, that means that the hydrogen chloride is definitely a sign for it. Right, okay, so that was remember that sodium chloride doesn't produce chlorine gas, but the other halides have a greater reducing power. Okay, so we're going to have a look at sodium bromide now. Okay. Right, so I'm expecting something slightly different now. Okay. Because of the greater reducing power. Alright, so usual struggles with salts. Okay, let's turn it into a pound. I'll add it to one section here. Okay. Alright, so let's do this very quickly. You know, everyone's time is valuable. Here we go. All right, we're ready with this. So the same reaction occurs to make the hydrogen bromide, but we should see a colour change indicative of bromine being formed as well. So there's several different reactions that should take place. There we go. So there's a gas. Now what we're hoping to see is a colour change, and indeed there it is. Can you see that? So that is actually bromine being produced. Bromine is something that we're very respectful of. So it's actually dissolving in the solution that's there. So that is bromine. I've got a couple of people watching this, perhaps the first time that they've ever seen bromine. You have to be very careful with this. And that's definitely different. It's definitely different to the first one. Okay. Right. What I will do is I'll put a text and I'll show all of the different reactions that are taking place. And now what we're looking for is we're looking for iodine. So that one worked really, really well. And again, the reason why we're, so this should also come up with, there's all sorts coming from this. There's also sulfur compounds that are coming from this as well. So I have to keep that contained for everyone's safety. Okay, so this is sodium iodide now. Okay. Spatula, okay. Oh, there it goes. Don't pick it up. Just leave it. I'll pick it up. Just in case it's got some halide. Should be fine. Quantities that we're talking about are very, very small. So I don't have any cyclohexane to separate this out. If I did, I wonder whether it would go purple, but who knows what kind of reaction could take place. Right, okay, so we're looking at a difference between the sodium bromide and the sodium iodide. Okay. Alright. So here we go. Oh wow! Immediately. Okay. Wow! In actual fact, we've got iodine. We can see very clearly the iodine, signs of iodine.
So I'm allergic to iodine.
Maybe. Well, it's okay because this is contained. Now, in and amongst that, there's also this yellow substance, and that's the sulfur. So because of the reducing power of the iodide, you are getting sulfur forming as well as, I believe, sulfur dioxide. Okay. Now, I'll lift it up a little bit just to add a bit more of this. But look at that. There we go. There we go. Isn't that fabulous? Amazing, no? Wow. I didn't expect it to be that successful, but I think that's definitely, definitely a go. So there you have it. The reactions of concentrated sulfuric acid with the halogens. Okay, the good, oh, can you smell a bad smell? So you will get a tiny amount, of this sulfur dioxide coming out. We're in the outdoors area. It's more of a pong, but it's minimized. Yeah, hydrogen sulfide is probably going in there as well at the same time. So there you go. Like and subscribe. Hey, brilliant. That's it.